Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be covering 6.3, which is transforming exponential functions. Again, all of Unit 6 is a review topic. We've covered this in Integrated Math 1 and 2 before, so it should be familiar. But all the same, we'll still go through it. Hopefully it'll sound familiar as we continue to do so. So as an extension of 6.2 really just asked you to be able to graph because we have Desmos at our disposal. Since we're doing this all online, it's a little less relevant, but still important to learn. The parent function of exponential functions we've expanded a little bit. Y equals a times b to the x is typically what we write, but because we're talking about translations, we've added in that h and k. H and k we've seen before in absolute value functions, quadratic functions, cubic functions, all different types of function families that you've graphed already throughout this year and last. So you should know by now what h and k do to your graph, but we'll still review it all the same. With Desmos, you can of course always add these sliders in and sort of just play around with it and see what happens to the graph as you continue to change it. So to start out, h and k, as always, any change that you're making to the outside of a function, k being on the outside, it's not next to your variable, that will move your graph up and down. So if I wanted to move the graph up 1, then I would change this to be plus 1. And if I wanted to move it up 3, then I would change it to be plus 3. Now, something that's important to note about exponential functions, for most of our function families, we have sort of a starting point at the origin. However, that's not the case here with exponential functions because something to the 0 power is 1 by your 0 power rule of exponents. Our starting place is 1, so some students get that confused. If I, let's say, wanted to move it up 3 spaces, for instance, then some students, if they were sketching it, might sketch the graph through 0, 3, but our starting point was 0, 1, so if I move it up 3, it should be going through 0, 4. So be careful with that. And then vice versa, from the starting point, if I wanted to move it down 2, then I would change it to be minus 2, and if I wanted it to be down 5, then I would change it to be minus 5, etc. That change in k is the same for all your function families. Similarly, h is going to move my graph left and right, as is the same with all the other function families that we've covered. The equation is written as x minus h. So, as always, because that minus sign is there, it sort of inverts what we would normally think of as left and right. We're used to thinking as positive on a number line going to the right, and negative on a number line going to the left. But because the minus sign is there, it switches it. So if I have a minus up top, it's actually going to move it to the right. And if I have a positive up top, it's going to move it to the left. So if I wanted to move it, let's say 1 to the right, then it would be x minus 1 in the exponent. If I wanted to move it 3 to the right, it'd be minus 3 in the exponent. And vice versa, if I wanted to move it to the left, 2 spaces, then it would be x plus 2 in the exponent. If I wanted to move it left 4, it'd be x plus 4 in the exponent. So very common mistake to make, even though we've covered this multiple times with different function families. Remember that that minus sign is there, so it's going to switch the left and right directionals, if you will. Another thing to keep in mind, now if we were in person, I'd be asking you to sketch this, and part of sketching an exponential function is not only sketching the function itself, but you also need to sketch what's known as the asymptote. We've covered this topic before with different function families, but an asymptote is a line that a graph approaches but does not cross. So in this growth model, because it's going up, if I look at the x-axis, even if I zoom in super close, you'll notice that that line does not cross the x-axis, even if I continue to zoom in and in and in and in. Because I can continue to divide a number, even take something simple like dividing a number in half, you can continue to divide that number in half over and over and over again, and you'll never get to 0. So what that does is it creates a line known as an asymptote. Here, for the parent function, our asymptote is the y-axis, or sorry, the x-axis. If we were in person, I would also ask you to sketch that as well, and typically you do it as a dotted or dashed line. You can do that on Desmos as well here, just to indicate where your asymptote is. As I change my k value, the asymptote will also change. So if I move the graph, let's say up 1 space, then my asymptote line would also move up 1 space. So it's not always the y-axis, it's not always the x-axis. it'll change based on where we move our graph, up, down, left, or right. For our purposes, I'm trying to make these as simple as possible, so there's no decimals involved, nothing crazy. You are going to be given a function, and you're going to be asked to translate that function and give the equation. So if, just like we did with quadratics, just like we did absolute value, I might ask you up 3, down 4, up 3, right 4, what's the equation? That's basically what you're doing here in this assignment. One other thing that you can change, remember that B, if B is between 1 or higher, then it's a model of growth. If that B value is between 0 and 1, it models decay, right? So it'll go the other way if you have a fraction there that's less than 1. Whether it's a growth model or a decay model, the translations specifically are going to remain the same. So H and K will work the same way, whether it's a decay model or whether it's a growth model. The one other transformation you're asked to identify is a reflection. So in this case here, I'm showing you y equals 2 to the x plus 1. But if I change the leading coefficient, just like any other function family, if I change the leading coefficient to be negative, then what it's going to do is it's going to reflect the graph across whatever my asymptote is. It won't always be the x-axis. If it's the parent function, yes. But whatever the asymptote is, when I change a to be negative, it's going to reflect that graph. So that's one other transformation that you need to be familiar with as you're going through this assignment. Okay? So let's look at a couple examples here. Say I start out with y equals 2 to the x, and I ask you to move it left 2 and up 1. So you would tell me, using the equation editor preferably, left 2 and up 1, that would be x plus 2 to move it left 2, and then up 1 on the outside would be plus 1. My preference is that you guys are using the equation editor. That's one of the reasons why we use Schoology. However, if the equation editor is down for some reason, or if you are forced to use simple text, be sure to include your parentheticals. We've talked about this before, but remember that your caret key, which is above the 6 on your keyboard, that indicates an exponent. So if I'm moving it left or right, I need to include that in my parentheses. And spacing helps also just for readability. You don't have to put the spaces, but it makes it a little bit easier for me to read. So if I wanted to, let's say, move it left 2, what we just did, then I would need to put x plus 2 inside the parentheses, and then plus 1. Because if you don't put the parentheses, I don't know if you're moving it left or right or up and down. So any left or right movement needs to be inside the parentheses if you're doing the simple text. If you're typing it into Desmos, then it'll just automatically generate that for you. Okay? As I mentioned, it doesn't matter if it's a growth or decay model. So, if the base is, let's say, 1/2, the change is going to be the same. So we'll start out with 1/2 to the x. We have a decay model here. And let's say I ask you to move it right 5 and down 2. So I will have y equals 1/2. And I said right 5 down 2. So when I do that caret, again, I want that in parentheses. Okay? I need to make sure that that minus 5 is up top, not on the side. And then down 2 on the outside would be minus 2. Because we're using Desmos specifically, because we're doing this online, you can use Desmos to verify your answer. If you're not sure, like let's say you get the left and right directionals confused, you can always type it in and see where it moved it. So if I wasn't sure this was minus 5 or plus 5, I can verify that just by typing it in to Desmos and seeing where it moves the graph. So that's another tool that you have at your disposal. That's it for 6.3. If you have any questions, reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.